All right, everybody, here we are, video number 3 at our journey into the polar coordinate system. Our focus on video number 3 is this conversion between polar and rectangular equations. So if you remember from video 2, one of the big things that we looked at were these series of these 4 equations where you have x equals r cosine theta, y equals r sine theta, r squared is x squared plus y squared, and the tangent of theta is y over x. So these 4 equations are really going to be the backbone, not only between converting from polar coordinates to really between coordinate systems, but it's also between equations. And what do I mean by that? So let's take a look at our first equation. Our first equation is simply x equals 5. If I look at x equals 5, and again, I'm always a visual person, I want to say, what does x equals 5, what does that look like? That is a line, and that is the vertical line that looks like so. So how do I draw a vertical line, or how do I equate a vertical line into the polar system? Well, if I know that x equals r cosine theta, so r cosine theta equals 5, and then if I solve for r ends up being 5 divided by cosine of theta, or r equals 5 secant theta. So really, this line x equals 5, I could actually write as r equals 5 secant theta. And believe it or not, I can actually do that in this graphing calculator. I do need to change my mode. So, oops. So I need to change my mode, that I want to change it into a polar mode, where if I said, okay, r equals 5 secant of theta, let me get my theta. And if you see, this looks like that vertical line, x equals 5. All right, well, y equals -3. I could do something similar. If I know y equals -3, again, I always like to try to draw it out if I can. Y equals -3 is the horizontal line down here. So I know y is equivalent to r sine of theta is -3. So r will be -3 divided by the sine of theta. If you remember, if you divide by sine, that's equivalent to multiplying by cosecant theta. So r equals -3 cosecant theta. Let me go ahead and change my equation. Instead of 5 secant theta, let's change that to -3 cosecant theta. Theta. Boom, there's my line, y equals -3. Well, what about not just a vertical or horizontal line? What about this? Y equals -square root of 3 over 3x. Okay, y equals -square root of 3 over 3x. What does that line look like? It has a negative slope. It looks something like that. So how do I change that into something polar? Well, if I know, and this is going to be very unique, we've never done this before, but if I divide both sides by x, I get this equation that's y over x is -square root of 3 over 3. And why would I do something like that? Well, I know that y over x is equivalent to tangent of theta. So tangent of theta is what I can replace the y over x with. Tangent of theta is -square root of 3 over 3. So theta ends up being the inverse tangent of -square root of 3 over 3. If you notice, there's no radius here. This is just an equation that's based off of theta. What is inverse tangent -square root of 3 over 3? That theta ends up being -π/6. And how does that relate to the graph that I have here? What this says is this is now an equation that's based purely on my angle, that the radius can be anything. So if my radius is positive, it goes in that direction. If my radius is negative, that goes in, or it goes in that direction. So this is very unique that we now have an equation that's based purely off of theta rather than on the radius, which goes back to what I said, that we no longer really have an independent or a dependent variable. They're really truly codependent upon each other. So, well, what happens if I have a parabola y equals x squared? So something I am going to do is on my graph here, let me go ahead and change this back to function notation, and let's graph y equals x squared. So we can see what that looks like on here. Now I am going to go back to polar, and we are going to create a polar function that's going to be equivalent. I should have showed you this before, but those were easy lines that we had. So y equals x squared. Well, I know that y is r sine theta. I know that x is r cosine theta. So r sine theta is going to be equal to r squared cosine squared theta. And I've never encountered anything like this before. Excuse me. So since I haven't encountered something like this before, what do? Well, direction said solve for r where appropriate. So let's see if we can solve this thing for r. So to solve for r, notice if I divide by r, kind of makes life a little bit simpler. I have sine theta is r cosine squared theta. Now to solve for r, I need to divide by cosine squared. So I'm going to put the r on this side. So r is going to be sine theta divided by cosine squared theta, which I'm going to write it a little bit creatively, looking like that. So sine of theta over cosine theta, if you remember, is equivalent to tangent theta, and 1 over cosine is equivalent to the secant of theta. So in the graphing calculator, I am going to put tangent of theta. Oops, I don't want the trig. I want theta. So tangent of theta times the secant of theta. Let's go ahead and get that theta back out here. And if you notice, that ends up being the exact same function I have right there. And unfortunately, this graphed it in blue. But if you notice, it gives me the exact same equation. So this tangent theta secant theta is equivalent to just y equals x squared. Now, if you look at it, say, okay, well, which one's going to be more beneficial? It really depends on what system you'd like to use. Next one, x squared plus y squared equals 4x. Well, this one's kind of set up nicely for us. And if you remember, the x squared plus y squared does equal r squared. So we can simply write that as r squared equals 4 times, and we know that x is equivalent to r cosine theta. So we have r squared equals 4 times r cosine theta. Now, suppose you actually didn't remember that. You could say this is r squared cosine squared theta plus r squared sine squared theta. Factoring out the r squared, we get cosine squared theta plus sine squared theta. If you remember that awesome identity, that's equivalent to 1. Boom, we get the exact same thing. So r squared is 4r cosine theta, where once again, divide by r, we will get r equals 4 cosine theta. So r equals 4 cosine theta does give us this equation. And if you are wondering, well, what does that look like? What does that look like? Let me go ahead and graph it for you. This is something that you guys should be somewhat familiar with, 4 cosine theta. And you say, how am I familiar with this? I've never seen this before. If you look at that, you see that's a circle. And yes, we have graphed circles before. So we graph circles. What is that circle in the Cartesian system? This is a circle with a radius. Well, how about the x is shifted to the right 2? The y is not shifted. And the radius of that circle looks to be 2. So that would be the equation in the Cartesian system that we are more familiar with. Now, if we actually multiplied it out and solved, we would get that equation that we have up there. So as I said, it is something that you are familiar with, but you just haven't seen it in this form. And this is really what I call about talked about the journey of mathematics. This is journeying into something slightly newer. And in many ways, it's more fun just because we sort of exhausted a lot of different things in the Cartesian system. So let's change it and let's do something new. So if you look at example number F here, or letter F here, example F, this once again is another circle. The circle should be centered at 3, -4 with a radius of 5. So what I'm hoping for is when we convert this into the polar system and we graph it, we should be able to see what the circle actually looks like. So how do we convert this into the polar? Multiply it out. Let's FOIL. X squared minus 6x plus 9 plus y squared plus 8y plus 16 equals 25. And if we subtract 9, subtract 16 from both sides, conveniently, that equals 25. So I now have x squared minus 6x plus y squared plus 8y equals 0. And I'm going to say, wait a second, this was a circle, this E was a circle, so F is the circle, something similar. Let's look back to what we already know from E. Let's take it into that x squared plus y squared form. And some of you are going, how am I supposed to know that? Well, you're not. So this is the process of how do I take what I've done before and convert it into something new. That's that journey of learning. So if I write it this way, once again, I could say my x squared plus y squared does equal r squared. My x is r cosine theta. My y is r sine theta. And once again, if I divide by r, I will get r equals 6 cosine theta minus 8 sine theta. So let's go ahead and put that into our equation. So r ends up being 6 cosine theta. So 6 cosine theta, and then minus 8 sine theta. Let's get that theta in there. And boom. Once again, we do have a circle centered at roughly 3, -4 with a radius of 5. So I believe we're on the right track. Yay, we've gone from rectangular to polar. Well, how do we go backwards? Going backwards, once again, we are going to use the formulas that we have here. What do we know about r? What do we know about r squared? How do we change our x squared and y squared? How do we change our r squared and x squared plus y squared? How do we change our r's into x's and y's? Really, these formulas, these 4 equations are going to be the key cornerstones to everything that we do, converting between the two systems. So theta equals 4 pi over 3. Well, if theta equals 4 pi over 3, that looks pretty similar to what we did in C up here, where if we had an answer where we just had a theta, if we kind of take that knowledge and work backwards, how do I go from theta equals backwards? Let's take the tangent of both sides. So tangent of theta equals the tangent. Let me show that I'm taking the tangent of both sides. Tangent of theta equals the tangent of 4 pi over 3. What is the tangent of 4 pi over 3? 4 pi over 3, if you remember, is down here. Oh, that tangent is square root of 3 over 3. Oops. I'm sorry, it's just the square root of 3. And if you remember, tangent of theta is equivalent to y over x. So we have this nice line, y equals the square root of 3x, which matches up with what I drew here. On to part B. R equals -5. I've never seen anything before where it was just R equals -5. Kind of curious, what would this actually look like? R equals -5. Let me go ahead and go to the calculator. What would R equal -5 look like? Oh, a circle. Okay, so if you remember from geometry that a circle is really just a shape that's based off of a radius, the polar form really highlights that kind of idea that we now have a radius that generates the entire circle. So by saying R equals -5, that means that we have a circle. And how do we get that into our rectangular form? We square both sides. So we have R squared equals 25. And if you remember, we're going to change R squared into x squared plus y squared. And hey, that is a circle centered at 0, 0 with a radius of 5. So what I love about the polar equations and polar coordinates and polar everything is it really brings all of our knowledge back together. You know, takes us back into geometry, takes us back into the beginning of trigonometry, takes us back into the stuff we did way in chapter 1 when we started talking about circles even. R equals 5 secant theta. R equals 5 secant theta. Well, what happens if I divide both sides by secant? By the way, we should have seen something like this before. R equals 5. Hey, this is the exact same equation. Go figure. So if we divide both sides by secant of theta, we have R over secant theta is 5. Or I don't like to say divide by secant, because if you remember the reciprocal of secant is cosine, that would be r cosine theta is 5. And personally, that's how I actually do this. I will say r times cosine theta equals 5 secant times cosine theta, because I know those reduce to 1. So r cosine theta equals 5, so x equals 5. Bummer, it's the exact same thing that we did before, so x equals 5. R equals 4 sine theta. So r equals 4 sine theta, is that like what we did up here? And happily, no. R equals 4, I say happily, you guys are like, man, I wish it was that easy. So r equals 4 sine theta. R equals 4 sine theta. Just because I can play with this, I'm going to. What does r equals 4 sine theta look like? So r equals 4 sine theta, because hopefully this will give me some insight as to what kind of rectangular equation this looks like. Ooh, that's a circle. So I'm going to have to manipulate this to get this into a circle. I think I actually have a negative still in there. That shouldn't affect too much, believe it or not. What it affects is where it's going to be, but it's still a circle. So the fact this is r equals 4 sine theta means that we're going to have to turn this into a circle. Well, the way we're going to do that is we are going to multiply both sides by r. So 4 times r sine theta. And what you should see is the reason why we're doing that is this side becomes the 4y. This one is our r squared. And by changing this into rectangular, r squared is equivalent to x squared plus y squared. 4y, and then we could put this into its circular form that we knew about by bringing the 4y over, and now we get to, yay, complete the square. So y squared minus 4y plus 4, if I add 4 to both sides. So now I have this as x squared plus y minus 2 squared equals 4, which does match up with what I have on the graphing calculator. So taking that next step, r equals 2 sine plus 6 cosine. If you notice, this actually looks very similar to what happened in F. And we're going to solve the same way as we did on letter D here. We're going to multiply both sides by r. Let me show that this way. So now I have r squared equals 2r sine theta plus 6r cosine theta. So x squared plus y squared would equal 2y plus 6x. Bring those to one side. I have x squared minus 6x plus y squared minus 2y equals 0. Complete the square means we have to add 9. If you remember completing the square, we have to take negative b, or sorry, take b divided by 2 and square. That's how we're going to get that. Negative 2 divided by 2 is 1. Negative 1 squared is 1. So this is x squared minus 6x plus 9 plus y squared minus 2y plus 1 equals 10, or in a much happier way, x minus 3 squared plus y minus 1 squared equals 10. And then we get to this one, r equals 2 over 1 minus sine theta. Wow, that one looks incredibly weird. It's like I've never seen anything like that before. So what I'm going to do is I'm going to graph it to say, okay, what do I think this is going to look like? So, or what would this look like so that I know if my equation is going to look proper at the very end. It needs to be a sine of theta. And wait a second, that shape looks like a parabola. Okay, so this is a parabola. I know that this is going to turn into a parabola, so it's going to be my job to put this into a parabolic form that I'm used to. Well, how am I going to do that? The way I'm going to do that is I'm going to multiply both sides by my denominator, 1 minus sine theta. So by doing that, it actually, you'll see it's going to make life a little bit easier. So I will have r minus r sine theta equals 2. And the reason why I like that r sine theta is because, hey, that's y. So r minus y equals 2. and I'm going to take that to the other side. So r will equal y plus 2. And now, how do I get this? I have a mixture of r's and I have a mixture of y's. What I'm going to do is I'm going to square both sides. And by squaring both sides, I now have r squared equals, let's go ahead and say y squared plus 4y plus 4. This r squared turns into x squared plus y squared is y squared plus 4y plus 4. And so if I subtract y squared from both sides, I will get x squared equals 4y plus 4. So x squared equals 4y plus 4. You guys aren't used to seeing in this form. Honestly, the form that we are going to be experiencing in chapter 10, this is only chapter 9, it'll look like this, which if you notice, this y plus 1 ends up being a vertical shift down 1. So as I said, we're going to talk about this when we get to chapter 10. What you guys would probably see it is more in the form, let's go ahead and work with this and say x squared minus 4 equals 4y, y equals 1/4 x squared minus 1, which actually shows that vertical shift down 1 as well. So, well, I hope you enjoyed this venture into polar coordinates. We're going to get to do a lot more fun with this as we get into section 2, where section 2 is going to be talking about like all these various graphs and all these amazing graphs we're going to come up with. But we'll have to stay tuned until next time. So signing off, remember for all of your math needs, I've got your back and you've got your back.